Betelgeuse. Betelgeuse, a red supergiant located about 640 light-years away in the constellation Orion, is one of the most studied massive stars in the sky. With a mass roughly 20 times that of the Sun and a radius nearly 1,000 times larger, its outer layers would extend beyond Jupiter's orbit if placed at the center of our solar system. Astronomers observed dramatic brightening and dimming events between 2019 and 2020, leading some to speculate that it might be on the verge of collapse. In reality, Betelgeuse is expected to explode as a supernova within the next 100,000 years, releasing an energy output of about 10 to the 44th power joules in seconds. The resulting flash would outshine the full moon in Earth's night sky and remain visible for weeks, perhaps even during the day. Supernova threat. A core collapse supernova unleashes roughly 10 to the 44th power joules of energy in just seconds, producing lethal bursts of gamma rays and X-rays while blasting shockwaves outward at nearly 10,000 kilometers per second. Such an explosion could sterilize planets within about 50 light-years, stripping atmospheres and erasing surface life, though interstellar dust clouds might offer limited shielding for more distant worlds. While Earth lies outside the critical danger zone of nearby candidates, the destructive potential of these stellar deaths underscores the unpredictability of cosmic hazards. Gamma-ray bursts. Gamma-ray bursts were first detected in 1967 by the U.S. Vela satellites, which were originally designed to monitor nuclear tests on Earth. These bursts are narrow, high-energy beams lasting from just a few seconds to several minutes, yet they release more energy than entire galaxies during that brief span. If one were directed toward Earth, the radiation would obliterate the ozone layer almost instantly, exposing the surface to deadly ultraviolet light from the sunday. Astronomers now classify them into short and long-duration bursts, typically linked to neutron star mergers or the collapse of massive stars into black holes. Because their beams are so tightly focused, the odds of Earth being hit are low, but the consequences would be immediate and catastrophic. Eta Carinae. Eta Carinae, located about 7,500 light-years away in the Carina constellation, is one of the most massive and unstable stars ever observed, with a mass estimated near 150 times that of the Sun. In the 1840s, it erupted in a colossal outburst, ejecting several solar masses of material into space and briefly becoming the second brightest star in Earth's night sky. The expanding gas and dust from this event form the Homunculus Nebula, which Hubble Space Telescope images have revealed in stunning detail. This eruption, often called the Great Eruption, did not destroy the star, but it demonstrated just how unstable such luminous blue variables can be. Astronomers believe Eta Carinae is now nearing the end of its life, and could collapse into a supernova or even a hypernova at any time within the next several 100,000 years. Rigel, the brightest star in Orion, and located about 860 light-years away, is a blue supergiant with a mass of roughly 21 suns and a luminosity around 120,000 times greater than our own star. It is considered a future candidate for a Type II supernova, as its core will eventually exhaust its nuclear fuel and collapse under gravity. Astronomers have monitored its variability in brightness using instruments like ESA's Hipparcos mission and the ongoing Gaia survey, which tracks subtle fluctuations in stellar light output. While Earth lies too far away to be destroyed by its eventual collapse, Rigel's supernova would still release a powerful burst of radiation capable of disturbing our planet's upper atmosphere. Such an event would dramatically change the night sky. Neutron star mergers. In 2017, astronomers detected GW170817, the first confirmed neutron star merger observed through gravitational waves by the LIGO and Virgo observatories. These collisions occur when two dense stellar remnants, each only about 20 kilometers in diameter but more massive than the Sun, spiral together and release energy on unimaginable scales. The merger not only produced gravitational ripples in spacetime but also triggered a kilonova, an explosion so luminous it briefly outshone an entire galaxy. Such events also generate short-duration gamma-ray bursts, releasing radiation powerful enough to sterilize planets across vast distances if aimed in their direction. T-Tauri stars. T-Tauri stars are young, unstable stellar objects less than 10 million years old, still in the process of contracting toward the main sequence. Named after the prototype star in the Taurus constellation, they exhibit intense magnetic activity that drives powerful stellar winds and flares. These outbursts often release strong X-rays, disrupting the atmospheres of any forming planets in their systems and making the early environment extremely hostile to habitability. Astronomers have studied them with X-ray observatories like Chandra, revealing how their violent energy output can strip protoplanetary disks and hinder planet formation. While they represent the first stage of stellar life, their instability also makes them reminders of how precarious planetary development can be. Just as stars can begin with destructive chaos, many will also end with catastrophic violence, as the eventual fate of our own sun demonstrates. Solar supernovas? Despite its central role in sustaining life on Earth, the sun will never end as a true supernova because it lacks the required mass. Instead, in roughly 5 billion years, it will exhaust the hydrogen in its core and expand into a red giant, reaching a size large enough to engulf Mercury, Venus, and possibly Earth. During this phase, its outer layers will be cast off into space, creating dramatic changes in the solar system's architecture. The remaining stellar core will eventually collapse into a dense white dwarf, surrounded by an illuminated planetary nebula that will glow for tens of thousands of years. This process is far less violent than the collapse of a massive star, yet it will mark the end of habitability within our system. The sun's predictable end contrasts sharply with the uncertainty surrounding more massive stars, whose collapses can release lethal radiation far beyond their home systems. This comparison underscores why astronomers classify stellar dangers by size and stage of evolution. Cosmic distance safety. Astronomers estimate that a supernova must occur within about 30 light-years of Earth to pose an existential threat, as radiation beyond that range typically weakens enough to avoid planetary sterilization. Fortunately, Earth sits well outside the immediate danger zone of nearby candidates like Betelgeuse, which at 640 light-years away would dazzle the sky but not destroy the biosphere. However, certain Wolf-Rayet stars and other unstable giants much closer could still generate dangerous gamma-ray bursts if aligned toward us, making vigilance essential. Interstellar dust and Earth's atmosphere provide some shielding, but these defenses are limited against direct, high-energy radiation. To mitigate uncertainty, global monitoring programs continuously scan the skies for variable stars, gravitational waves, and transient signals that may indicate looming stellar collapse. Because predictions remain imprecise, the search continues, ensuring humanity is not caught off guard by the universe's most violent events. Final unknown. Astronomers cannot assign precise timelines to stellar collapses, since even detailed monitoring of candidates like Betelgeuse leaves uncertainty spanning thousands to hundreds of thousands of years. A supernova could erupt tomorrow or remain dormant for cosmic ages, with no visible sign of imminent disaster. Stellar interiors remain inaccessible to direct measurement, and surface fluctuations reveal little about the true state of a star's core. Because of this, predicting the exact moment of collapse remains one of astronomy's most stubborn challenges. The only possible early signal may come from a burst of neutrinos, ghostly particles released during a star's core collapse hours before its light reaches Earth. Even then, the warning window is short, providing little time to respond to such a catastrophic event. This profound uncertainty emphasizes how the universe's most violent and transformative events remain beyond our ability to forecast, leaving humanity perpetually exposed to cosmic surprise. Antares, the red supergiant marking the heart of Scorpius, lies about 550 light-years away and has a mass roughly 12 times that of the Sun. With a radius estimated at 700 times solar, it is already in an advanced stage of stellar evolution and nearing its inevitable collapse. Astronomers expect Antares to end its life as a core collapse supernova, releasing more energy in seconds than the Sun will emit in its entire lifetime. Such an explosion would be visible even in daytime and could flood nearby space with high-energy radiation. Though Earth lies just outside the most dangerous radius, a supernova this close would still have the potential to disrupt the planet's upper atmosphere, damage satellites, and increase harmful radiation at the surface. Because of its proximity and size, Antares remains one of the most closely watched stellar giants, serving as a reminder that familiar stars in the night sky can harbor catastrophic potential. Its fate ties directly into the broader cosmic pattern, where massive stars end violently and alter everything in their neighborhood. If you enjoyed this, I'm going to be posting a lot here. I would greatly appreciate it if you could subscribe. Thanks for watching.